And looks like we are live and ready to go. Good evening, everyone. So just before we start, a couple of little key caveats here. First of all, I do have a little bit of cold, as you probably can hear. And so I do apologize if I sniff a little bit after throughout this whole chat. Hopefully I don't sneeze. That'd be funny. Also, we're doing this a day earlier because it is a very special birthday tomorrow. It's my wife's birthday, so everyone wish her a happy birthday, because or not, I don't know, but I would say wish her a happy birthday. And there's the first sniffle. Um, it is an interesting past couple of days because we've gone from model guidance going for an all-out blizzard to a few flurries, if that. So we talked about in the last live chat that this was an all or nothing event because, and we also said this on, I also made a video of the premium public video discussion saying that this phase situation is such that if it didn't phase just right, you'd get almost nothing. So I was skeptical of the idea of a perfect phase, especially in this weather pattern. And the reason why this weather pattern is not conducive for perfect phases is because we are in a positive QBO state. Now, that doesn't mean you can't have a perfect phase in a positive QBO phase, but you need everything to line up perfectly for that, because the nature of a positive QBO is that the jet streams are out of alignment. So that's why you typically don't see a lot of sustained high latitude blocking, because the polar jet stream is booking and the subtropical jet stream is in a different position. And so they don't line up properly. Green tea, by the way. So drinking that all night rather than coffee. So that's why we're at where we're at. And that's why I was skeptical to begin with. Now, we also had the NAM guidance, especially the 12Z model guidance this morning, produced some very interesting solutions, which of course got some individuals very, very excited. I'm going to show you guys how to pick out a bad model, and so that way you don't get caught up into it. And this NAM example is a perfect example of that. So I'm going to show you that this evening as well, and also take a look at where we're going in terms of this weather pattern. So we start off first with the polar vortex, and it's still going through a stretching regime right now, which gives us a shot for one more Arctic blast, but it's going to be far more limited than what we've seen previously. Why? Because after this stretch, there's that final stretch, then it consolidates, but more importantly, it shifts. You see, for a while, it's been going from north to south, right? So even when it doesn't shift, you still have that northwesterly flow. Now, as we head into March, it is shifting its orientation, not only contracting, but shifting so that the stratospheric winds are going to be moving from west to east, which means you don't have the capability for the polar jet stream in the troposphere to dip down and remain in a northerly or northwesterly component. Instead, it shifts more towards a zonal setup, which means Pacific air. So I've been advertising this evolution, the polar vortex, for the end of February and the start of March. Going back, you could say, I mean, I am going to say it, September, October, and then I reinforced it in January. So this is what should happen. Get one more good stretch in mid-February, and then we'll start to see a shift more towards the spring pattern towards the final week of February and into March. And now we're just 15 days out now, and we can say that. Now, you might say, Stephen, we've seen storms forecasted 15 days out, but you always tell us don't worry about the details. That's very, very valid. This is a different scale. We're not looking at finer details. We're looking at the overall theme of the weather pattern. And so when you're talking about these broad brushes, I'm not saying that there can't be a cold day in early March. I'm not even saying that we won't see an Arctic blast. What I'm saying is that this setup here makes an Arctic blast last a day and then we moderate fast. This weather pattern makes it more likely for Pacific air masses to dominate rather than polar and Arctic air masses. And if you're looking for high latitude blocking, well, you have a better luck of getting a lottery ticket and winning with this type of orientation. So, in terms of the stratospheric forcing, I think we're pretty much at its end. Okay. In terms of the tropical forcing, this MJO in phases 8, 1, and 2 is very, very active for us. There will be no lack of storms marching across the country with this signal. And there will be no lack of interaction with polar air masses with this signal. The problem, if you're looking for major winter storms again, is that while you have that interaction without the blocking, your coastal plain is basically a cold rain in this scenario, maybe a wintry mix to rain, and your interior is a snow to wintry mix type setup. Even with this signal, the threat is more for the interior than for the coastal plain. In some cases, the interior might be talking about New England rather than the northern mid-Atlantic. Meanwhile, our SOI signal, which again is another tropical forcing signal, again, now that the MJO is moving through our cold phases in 8 and 1, we're now getting negative contributions. The influence of the La Nina signal is starting to fall apart again already. And don't be surprised as we head into March if the La Nina signal completely collapses as the MJO moves through these phases, the final next 15 days. So this leads to me saying, okay, not going to have a really strong southeast ridge type of component, have a lot of progressive systems, a lot of waves of cold air followed by mild air. We have one really sustained cold shot basically now through the end of the week. And then starting this weekend, now we're going to move into more of a roller coaster type scenario based on these contributions. Contracting polar vortex, active subtropical jet stream in cold phases. So a lot of storms cutting up towards central Pennsylvania, for example, and then a cold shot coming in, and then we moderate pretty quickly. So a lot of this movement. And so what this ends up with in the 500 millibar pattern is a 500 millibar pattern that features no real sustained high latitude blocking. So, for example, with the polar vortex lifting northward, this feature, which used to drop down here, is now stuck. You see how it is not able to drop further south? It's just kind of held up and stuck here. That's that That's a stratospheric influence here on the troposphere. So yeah, you get this deep trough that shows up around early March, but this is all transient, and the western edges is already getting moderated by a Pacific air mass coming right into the Pacific Northwest and dropping through the Rockies. And when it downslopes off the Rockies, it really is going to warm. So this signal is a transient cold signal for me, not a sustained cold signal. And I would not be surprised if a lot of the model guys will take a look at the European and also the European AI. You could look at the GFS. This time period, 15 days out, most likely the cold air mass being shown in the guidance is probably overstated a bit. So while I do like the idea of a cold shot, I think it's a transient, fast moving cold shot. This could also lead to quite a bit of severe weather, by the way. Don't be surprised in the Mississippi River Valley and down towards the Gulf Coast and around the Tennessee River Valley if we get a nice outbreak of severe weather out of this for early March. With this strong cold front, you got a nice surge of southwesterly flow out ahead of it. You have plenty of mild air coming out of the Gulf, and you end up with this clash here where you could get a nice line of strong severe thunderstorms marching through the Tennessee River Valley and the southeast. So this I would definitely put a note here for March 3rd through the 6th of a nice severe event marching right around the southeast and Gulf Coast during this time period. Don't be surprised about that at all. And a good rainfall event for us, which we clearly need. I mean, we've had a couple of storms, but we still need a lot of rainfall to really overcome our drought conditions. But one thing we don't have is any type of high latitude blocking. So this tells me that, look, you might catch us. Like, don't be surprised if some model guidance tries to turn this into more of a winter storm for us. I would not be surprised by that. We see some errors in that, but you have to look at the overall pattern, and the overall pattern is such I don't have any negative NAO. I have a very progressive flow out in the Atlantic. I don't have the ridge axis in the right place. I have a building upper level low shifting from the Aleutians to the Gulf of Alaska, and a very progressive flow at that with Pacific air streaming in. Your upper level low is far too north. Yeah, you have a negative tilted trough, but what's keeping the cold air in? And so your cyclogenesis is more likely on the coastal plain than on the coastal waters. So again, these are all little clues I'm trying to teach you to say, okay, so that way you're not up at 2 a.m. trying to wait for the European model to come out to see whether or not it's going to produce that snowstorm for you. It gives you a chance to kind of back away. Spending time with your friends and family is very important. Trust me. And you don't want to waste it looking for storms that don't fit the pattern, no matter how much the NAM says it does. So, in terms of the cold air masses in place, again, notice the difference here, right? When we start now, clearly Arctic air mass in place, right? And it had a nice connection up here with Siberia and a surge southward. So, this is our last Arctic connection. Then, as we move forward, there's that quick moderation. Gets these little brief cold shots, comes in, goes out, moderates very quickly. Another cold shot comes in, goes out, moderates very quickly. Then we get that last pull of a polar air mass coming in. But notice the difference here. The core does not drop south, it stays northward. It stays up in northern Canada, heck, north of the Hudson Bay. Whereas previously, the past couple of weeks, this core would drop south. This is a direct connection to the evolution of the stratospheric polar vortex, pulling everything northward. Everything's getting pulled northward. The polar jet stream is getting dragged northward. Reluctantly, violently, but it is getting pulled northward. So what you end up with is this air mass just tries to drop in. Don't be surprised if a lot of this moderates a lot quicker than what this guidance is showing. Why? Because your source region is getting cut off. And then here's why I think you have that severe set up really nicely, because clearly you have warm, moist air surging up the coast, and you have this polar air mass, even if it is not as cold as what's depicted here. Let's say it's around -6, right? You still have a pretty good cold air mass coming in there, marching towards the coastal plain. And then off to the west, look at a moderation quickly eating this away. So you could see the warm air transport coming right off of the Rockies with this Pacific air mass coming in. So these are all signs that, look, we're moving towards a pattern change here, evolving. And so as a result, what you end up with is this very progressive pattern. There's our storm that's missing. You kind of get, honestly, I kind of have like a little bit of Charlie Brown vibes here. Coming in to kick the field goal. He's going to kick the ball and whoop, slips and misses. It's very, very, very strong urge to just post that all day on social media. And then after that, very progressive, low pressure systems. There's one heavy rainfall event. Again, there's your snow more towards the Great Lakes and towards New England. Very progressive pattern. And one which, again, I'd watch out for some severe weather down here. I would not be surprised if we get some pretty good severe events out of this. And by the way, this setup also opens up the potential for some icy conditions setting up for Poconos, Catskills, Connecticut, Hudson River Valley, being a real pain. So it could be something where you get a little bit of sleet. Probably the malls will advertise snow a couple days out. Then it trends more to like maybe an inch of snow and a lot of sleet and freezing rain. So if you have concerns about that, in the Poconos and Catskills, we've already seen quite a bit of ice already. I would not put away your ice gear just yet and your snow melt and ice melt. I think you're going to still need it up in those locations. But I think for going forward for the coastal plain, it's going to be a lot of cold rain. I don't see much in the way of potential for snowfall. And in terms of the AI model, because a lot of people are starting to lean on this, look, AI model is interesting, but you cannot lean on it or any model guidance. You got to look at everything and kind of put it together. But the way you forecast it, you have to create a plan. You have to, based on the atmospheric conditions and what you're taught, you create a plan first, and then you look at how that plan fits into all these models. And each model has a positive and negative attributions in terms of their biases. And you have to work within those biases to create that forecast. So the AI model, it looks interesting, but we're still learning its biases. So I wouldn't lean on this a whole lot. But one thing I find very interesting with this guidance is it tends to kind of over amplify blocks, especially as you go towards the extended. But even when it does that, notice it also is keeping the core of the polar vortex way northward. And this whole trough signal here, this tells me more that, hey, look, this looks like a pretty good heavy rainfall event and a severe event. This really isn't a block because look at the evolution here. It's all moving west to east. This isn't a block. This is just a very strong ridge in response to a very deep trough. But everything keeps on moving. And so when you take a look at your 850 millibar temperatures, you have the same signal here. It's getting cut off from the core, and this is moderating quickly. So it's the same theme, just a little bit more amplified. So kind of half a dozen of the other. The overall theme here I'm trying to share is that we're moving away from the winter storm potential, and that's kind of the bottom line. In the meantime, right now it's kind of chilly. It's quiet out there. Notice how dry the air mass is. -1 degrees Fahrenheit for a dew point, and it's 23 degrees out. That's the type of dry air that gets your fingers all like crackling and not fun. Not fun at all. Although I think I might go outside just to kind of clear out my sinuses. That might help. I'm breathing that dry air. Break everything up. But this is some very dry air. And the reason why I want to show this is that for any plan or any idea of having a storm coming from the south that is moving very quickly to now drop a lot of snowfall, well, not only do you need the storm to slow down, but now you need, excuse me for a second, now you need a scenario where you you have to moisturize the atmosphere to the point to support snowfall and overcome all this low level dry air. So, in other words, a lot of the model guides you might see with an expanding precipitation shield, it has to overcome a lot of virga here. So that's a problem. Meanwhile, on our radar and surface map, well, we just have a little weak shortwave here moving through Virginia. Other than that, it is pretty quiet out there. And there is our storm. Okay, so here's the first couple of things we notice here. You see this feature here? This is part of the subtropical shortwave. Okay, this is in the subtropical jet stream. Then you got this feature up here. Let's draw this out a little bit and see if I can do this properly now. Okay, so here's our subtropical shortwave out here, and there's our polar shortwave right here. The idea is that this needs to slow down while moving, so that way this could catch up to it, and then boom, right? Problem, there's nothing to slow this down. So this is all just marching away. Boom, boom, boom. Fast, fast, fast. So my question, if anyone is saying, hey, look, it could still happen, okay, what's slowing it down? See, one of the things my professors taught me and made us do when we were in college is first stand up there and get humiliated, because then they'd start asking you about the equations and all that stuff, and then you'd have a brain fart because you can't think because you just got done with chemistry class. But I digress. Um, my professor would ask me, "Okay, Stephen, the forecast you're putting out a forecast is saying the storm's going to slow down because we all love snowstorms. What's slowing it down? There's no block. Everything's moving fast. What's going to cause the phase?" And so when you look at this, when you're looking at the satellite picture, if you're still holding on to hope, this satellite picture should kill it, because there's nothing to slow this down. It is just booking. You can also see that here on the water vapor satellite picture. Again, here is your shortwave way back here. There's your polar shortwave there, and here's your subtropical shortwave over here. And this is just moving. There's nothing to stop it. And this is a confluent flow. So again, what's going to slow it down? And that was the whole problem with this solution to begin with that I brought up a couple of days ago. And if you want further support, hey, I wish I had this when I was in college, when I was starting out. There is your whole jet stream at 250 millibars. So a couple of warning signs to a phasing solution. One, your short waves are moving into a confluent flow that is only getting faster. Your block is too far north. If this was down here, this feature right in this core was down here, this would all slow down. Boom, major storm. Of course, our luck, it'd probably end up too far south and then suppress it down towards Florida. But still, you kind of get the idea here. There's nothing to slow this down. And so that's why you don't get a full phase. So there is your short wave, all right, that is in the plains right now. It's out here by the time this really starts to get its act together. When these two start to interact, originally this was setting up off the Jersey Shore. Now it's way out in the Atlantic and it clears out. And again, it had to be a perfect phase because the rest of the pattern doesn't fit. And so when we take a look at 850 millibars, you see the whole storm development. The 850 millibar development, the mid-level storm development was all based in the subtropical jet stream, and it was already exiting out before it even had a chance. So this should kill any idea of accumulating snowfall outside of like Cape May and Wildwood. Okay. Now let's talk about the NAM model guidance, which produced this solution this morning. Now I think we can all agree that this solution was wrong. The question is, why did I automatically know it was wrong? Well, first of all, it's a mesoscale model, and you're trying to answer a synoptic question. So they're two different levels, right? Mesoscale is for things like mesoscale banding, snow banding, thunderstorm development, heavy rainfall development within a storm, stuff like that. This is a synoptic question, as in 500 millibar PVA, placement of the low pressure system, placement of divergence and diffluence. So when I look at this, the next thing I want to say is this looks like convective feedback. Why? Well, that feature right there, this right here, this right here, and this right here doesn't really add up, doesn't make much sense. Why is this explosions happening out here? What's the lifting parameters for this? And why does it allow for this precipitation band to expand like this? Well, one of the ways you can see whether or not there's some sort of error with the 12 kilometer is to take a look at the 3 kilometer. And the 3 kilometer starts to reduce this threat quite a bit and shuts down the precipitation shield very, very quickly. So it doesn't allow that full expansion. So that should be your first warning sign. Your next warning sign is to take a look at the mid-level and upper-level dynamics. So we pull up 500 millibars, and you take a look at this, and there is your warning sign right there. This doesn't make much sense. This is too close to this upper-level low, and it's not associated with the subtropical shortwave, which is out here. So this should have been your first warning sign. Next warning sign, 850 millibars. And take a look at the frontogenesis it tries to create. Doesn't make much sense. Trying to create this frontogenesis that gets this far north. How about 700 millibar frontogenesis? Same thing. A lot of strong, funky frontogenesis here. Now, does this line up with the 3 kilometers? Well, let's take a look. And no, it does not. It keeps it right off the coast. Produces a little bit over southern New Jersey, and then exits out very quickly. So these are all signs of convective feedback error. And so when you see this type of scenario, this is when you throw the NAM out very, very quickly, especially when it doesn't align with any other model guidance. There is no northwest trends or southeast trends or any of these other trends in model guidance. All it is taking the adjustments in the short waves and adjusting how they interact based on the observations that we have. And so that's pretty much where we are at in this scenario. I know a lot of you guys want to hear me talking about some sort of major storm or whatnot, but this isn't a hype channel, and I'm not going to tell you that a storm is going to destroy half the eastern United States every week like you might at other content. So now we're at the point where I'm going to take some questions, and we'll see where we're at in terms of social media land. Of course, everyone's wishing Susan happy birthday. Happy birthday, Susan. Hi. Let's see here. Let's see. All right. So, uh, Aaron asks, any thoughts on a potential major polar vortex disruption shown in the model towards the beginning of March? It's not really a disruption. It's actually pulling northward. Um, in fact, it's consolidating. So the GFS and by itself had this disruption, but none of the other Mogons, including the GFS ensembles, really supports that idea. You saw a deep trough at 500 millibars. That's not a polar vortex disruption. It's just simply a deep trough dropping through the eastern United States, and it retracts just as fast. So I don't really see a disruption. The stratospheric winds are going to reduce, but it's also March. They should. And they're not really falling much below normal at all. They're pretty much close to near average. So I'm not really seeing much of a major polar vortex disruption in this scenario. I see a brief Arctic blast that maybe lasts a day. So for one day, we'll drop to like 20, and then the next day we'll be back up to 39, and then 52, something like that. Let's see here. Polar jet, even when it's stretched and near split, I'm assuming you mean the polar vortex, has been very strong, far faster stream flow than the subtropical. Yeah, okay. Excuse me. With no chance of phasing. This is part of the positive QBO phase where the polar jet stream is very progressive. The polar vortex is very strong. This is why a negative QBO state typically opens up a better potential for some major winter storms. It's not a lock, but it's a little bit better. I hope things change for next season. We really need to get pit with snowless funk. I'm not saying we need blizzards. We just need 4 to 8 inch storms with a bunch of them. You know, snowballs, we did have that. Maybe not over your specific location, but we certainly had a lot of storms like that. It didn't line up so well in the Lehigh Valley, I agree. But in reality, snowfall totals came pretty close to near normal for the season. So we weren't that far off. The last storm was more ice than snow, granted, and we'll see what the final totals are in the snowfall season, once we get to the end of this month. But overall, this season has been pretty much as expected. I really wasn't expecting much in the way of major storms. I do expect a gradual shift to more and more snowier winters. We just need some patience. This is a typical phase. We see this. We've seen this for decades, for centuries, where we have some decades where it is snowing until you think that you might be able to build an igloo for a home, and then other decades where we see barely any snow at all. So we're just kind of stuck in that funk right now. Card says, I will say again, this reminds me of the winter of 77, 78, where it was very cold but not lots of snow. 77, 78 ended up having the cold air and moisture combined to create a couple big time snowstorms for the I 95 corridor, but timing was off the year before. Possible. Absolutely. Next year could be very interesting. All right, that's going to get me in trouble. Uh, Next year could feature a negative QBO and a weak El Nino. So you got a little bit better chance of seeing a couple of nor'easters out of that. But of course, my luck now, I jinxed it. And now it's going to be rain on the coast with so on and so forth. So disregard that. Do you see getting enough rain to put a dent into the drought? I do. I do see a shift. I'm seeing more and more support for MJO phases, more towards those wet phases, and staying out of the 4, 5, and 6. I do also think we'll see a little bit more active subtropical jet stream because we're going to move more towards a warm, neutral environment late spring and in the summer for El Nino. Well, not an El Nino, but more like a warm ENSNO type scenario. AI models have same issues as other models. Quality of data and the model design themselves are crucial. Yeah, absolutely. We have to continue to focus on good data coming in. Just imagine how cold it would be if we had some snow cover right now. Oh, definitely. Yeah, you're absolutely right about that. It'd be about 5 degrees colder. If you want to see an example of models showing storms, check out the 18Z GFS. I don't know if I want to. Do I want to? All right, yeah. Let's see what the 18Z GFS did. We'll pull this up. Let me pull up. All right, let's see. Let's zoom out here. We're using tropical tidbits right now, so we can take a look at everything. And let's see the comical analysis here. Okay, so it got this storm right. There we go. That's good. Got a nice little weak warm clipper. Oh, look at that. Trying to produce storm. So when you're looking at this, I know I'm going to sneeze. I can feel it. Don't you hate that feeling? You can feel the tickle in your nose and you know you're going to sneeze. Uh, yeah, that storm's a little silly. Come on. What is this model doing? 986 millibar low. Uh huh. All right. Let's take a look at the 500 millibar pattern on this. Okay. So, that. Let me go zoom out. North America. Okay. So it's creating this negatively tilted trough with no block at all. This isn't a negative angle block, by the way. This upper level low is way too far north. This feature is really more of a zonal pattern here. This is zonal. Uh, this is ridiculous. This is just silly. Let's see what else. And it tries to drop the trough in and then retreats it just as quickly. Yeah. GFS once again. Throw it into trash. Throw it out. Get some gasoline and burn it. My question about the 18Z GFS with the over under for what month and day it shows the first phantom monster hurricane. I give it June 15th. Let's see what we got on YouTube here. Oh, lots of activity here. Let's see here. Play of happy birthdays. How much snow? How much snow for Salisbury, Maryland? That's kind of outside my area. But I guess probably over a 3-inch mark, somewhere in the 3 to 6 inch range. 2010. Let's see here. Okay, 2010-11 was a positive QBO phase, and we saw a lot of winter storms. Also, the winters of 2013-14 and 2020-21 had many big snowstorms with positive QBO. It wasn't as strong in 2010, 2011. 2013, 2014 was more dominated by the El Nino event, and 2020 and 21 had a changing QBO as well. Now, with that, and here's like a lot of mistakes that a lot of weather enthusiasts make. It's never just one feature. Each winter, okay, each winter has a unique driving phase. Last year, it was the EVP influence disrupting the polar vortex combined with the changing state of Enzo, which was still in more of a El Nino state, right? The year before that was clearly dominated by tropical forcing and La Nina, not so much stratospheric influences. Then the year before that was a strong La Nina that Jay's basically screwed everything up. Then 2019, 2020 was the polar vortex consolidating in December that short circuited the whole winter. You guys remember that one. Um, so my point is that you cannot just focus on one feature. It's a combination. Okay, it's kind of like a combo platter. Okay, you're making a Chinese dinner, and you have to do the combination, right? And look at how each feature is interacting. This year, the state of the positive QBO, because all your tropical forcing is so diluted, stood out more as a contributor this year and helped drive and enhance the polar jet stream. Next year, that might not be the case at all. You could have a more established El Nino that overwhelms the pattern and really starts to drive the subtropical jet stream. And then the stratospheric influences have to come in as either an enhancement or as something to combat that forcing. So it's never an A plus B equals C. It's always A plus B equals X times a coefficient, and then add a whole bunch of other factors above that. So you can never just look at one factor here. That's what I'm trying to get at. Like, if you're going to look at each winter storm and to say, well, this one had a positive QBO and that one, yes, there are certainly years where we've had a lot of winter storms with a positive QBO. But that could be because the positive QBO influence was overwhelmed by other factors. So you cannot do much like with El Nino and La Nina. You can't just say La Nina's in force, and so therefore X, Y, and Z will happen for the winter. That's how you get a lot of bad seasonal forecasts because it's never just El Nino. It's never just La Nina. It's the interaction of all these features. If it was that simple to just make a seasonal forecast, it'd take me 5 minutes to write a winter forecast. Like, what is it? Oh, it's El Nino? Okay, it's this. Oh, it's La Nina? Okay, it's that. It's never that simple. Let's see here. Are you saying there won't be any more winter storms for the Northeast? I would say if you're in New England, you still got a pretty good shot. Maybe Poconos and Catskills. Let's see here. Another winter of below average snow. Well, it depends where you're at. It looks like the Poconos actually are running slightly above normal. Um, the coastal plain, pretty much as forecasted, below normal. But, honestly, though, I'm curious to see how Cape May looks. Because I tell you what, who got a lot of snow this year was Delaware, Maryland, Southern New Jersey. Southern New Jersey got a lot more snow this year than Central New Jersey. I can tell you that right now. So we'll see how it looks at the year end. Let's see here. Can place anything on X or Facebook? Is a major winter storm for I never go basically. Yeah, I'm not seeing anything. Is a Moduki El Nino better for us than an East Base? I would say a Moduki El Nino is better. It's probably the best one, as long as it's weak. You don't want anything moderate or strong. Holy smokes, we got a lot of. This is X? Yep. Holy crap. Well, X on the activity tonight. Let's see here. I'm going to be in and out with the. Stopping in to say hi. Awesome. Hello, GN photos. Um, Not done. Winter is not done. Lots more to go. I think it depends on where you're at. I definitely say that's true if you're in the Great Lakes. Let's see. It's done in Maryland. Winter's over. Winter's not over. You guys fight and have it out and let me know how it works. MJO looks great. It does. It does look great. MJO always looks great. MJO is a beautiful, beautiful forcing mechanism that looks beautiful all times of the year. Can't hear. Turn on your speaker. That always works. Um, does the March pattern support a shot at some 70s and 80s once we get past the 15th? I think 80s is pushing it, but a 70? You get a nice strong. I've seen it before. I mean, it's possible. I'm not going to say no, especially after March 15th. 80s pushing. That's a record high. Now you're talking about record high levels. I never like to forecast for records, cold or warm. Yeah, audio's working. Yeah, so I don't know. We would have heard it from everybody else anyway. Turn on your speakers. It does work for you. There you go. Long Island's winter threats are over. I would say so. I'm pretty much convinced of that. Let's see. Yeah, let's see while we're pulling that up. Is Rockland County considered the interior to still see? Yes. Yes. Rockland County is definitely beware of that. What else? That's not set up for a coastal storm. Agreed. Any chance for big snow in Hudson Valley, New York in March? The further north you are in the Hudson River Valley, the better chance you have for snowfall. Big snowfall, less and less likely because of the higher sun angle, the timing, the weather patterns just all off. But certainly a better chance than anyone else down here. That December polar vortex consolidation was the year that the mesosphere got so cold. Yes, that was the year where the mesosphere mixed into the stratosphere, made it so cold, consolidated the polar vortex, and made it so strong that by the time it weakened, it was late February. And so the whole winter was shot. And that was the winter leading up to it because there was no sign that the polar vortex was going to strengthen that much. In fact, there was a lot of talk about it weakening, right? So we as forecasters, certainly I, never thought like, hey, the mesosphere, the layer above the stratosphere, was going to dip in and interact with the stratosphere. So this massively cold layer dropped in, caused the polar vortex winds to speed up, caused the polar vortex to consolidate like a ball, and that was it. Winter done. Because all the polar and Arctic air masses in the troposphere got pulled up into northern Canada. I never even seen anything like that. And I was stumped. I'm looking at this in late December, and I'm like, how in the hell is this happening? It doesn't make any sense. There was no indication of this in any of the long range guidance. There was no indication of this in the observations. So I take a look at the stratosphere and I see this cold wedge dropping in from 1 millibar and 2 millibars. And I'm like, what the hell is this? It looked like something out of Ghostbusters 3 or 4, Ghostbusters 4, where like the cold demon comes in and freezes everything. or the day after tomorrow of next week of 2 days ago with the Arctic wolves, where the cold air just like comes in from the upper portions of the atmosphere, and I'm like, holy crap! Except when that cold air comes down from the upper portions of the mesosphere and the stratosphere, the Earth warms. It doesn't get cold, and everyone freezes to death. So this whole process caused the polar vortex to consolidate and completely screw the whole winter forecast. So yeah, I wasn't going to be able to forecast. If I had forecasted that, I would be a super genius. I wouldn't be doing this right now. I'd be locked up in some government facility, um, studying how the hell I figured that out. Sort of surprised that with the strong northwesterly wind, that there wasn't any ocean effects snow off the Sound of Long Island because the boundary layer is so dry. That's why. That's exactly why. Let's see here. Yeah. Let's see here. Winter forecast was perfect. Well, I think some people would disagree, but I appreciate it, Jeff. I do. I never try to look at a winter forecast as being perfect because I'm always trying to look for ways to better myself. As a young meteorologist, always look for the losses, look for the errors, because that will always make you a better forecaster later. You skipped my question. Well, I can't answer all your questions, Boris. You asked a lot of questions. I gotta let other people ask questions too. I heard about some experimental research concerning potential shutdown of the AMOC. Oh, okay. This is a good question. Can you explain your thoughts on the phenomenon and if something like this may happen during the next few decades? Okay. So there is a lot of research, a lot of debate on whether or not the AMOC is going to shut down. Um, First of all, if anything's going to happen, it'd probably start showing up around 2050. There's no indication right now of any slowdown. No change in the salinity, the speed, the transport of warm water. If it was to happen, the way it would happen was that, excuse me, basically you introduce a lot of fresh water from the ice melting on Greenland, which screws up the whole salinity balance in the northern Atlantic, which kills the whole circulation. So by killing the whole circulation, you shut down the warm air transport coming in from the tropics. So what this would lead to is essentially a massive cool down in Europe because you no longer have the heat being transported up towards Europe, and you'd also see a pretty significant cool down in the northeast of the United States. So you end up with a colder weather pattern, but also potentially a drier weather pattern as well, because you no longer have the support for significant cyclogenesis because of the warm water off the mid-Atlantic coast. So instead, you end up with a really cold, dry pattern as a result. Um, I don't think it gets to that point, but I do think there probably will be a slowdown. But the atmosphere has a way in creating a balance on all this. And there has been in the past this type of shutdown, and it always resets itself. So this is something to worry about. 2050, 2021, sorry, 2100, 2150. Talking about 50 to 150 years out could become an issue. Sorry about your Chiefs loss. Hey, look, they can't win the Super Bowl every year. Hey, they got there, which is better than a lot of other teams. And they'll be back there again. I'm not worried. They got to build their lineup. That's what they got to do. They got to focus on their offensive line. Can't throw to a wide receiver if the guy's already getting tackled. How could you get a major East Coast snowstorm without any phasing? Oh, absolutely. You can get that. All you need is a good clipper. You get a clipper dropping in from the upper Midwest and diving towards the mid Atlantic coast. You have blocking set up. There's no phasing involved in there. It just slows down the storm interacts with the coastal water, which are warmer, and the Arctic air coming in behind the low. It blows up, does a little bit of a pivot, drops a good heavy snowfall, kicks on out with the block. Were the snow flurries on Monday lake effect? No, at least not directly. Uh, Let's see. Let's go back to here. All right. Any early ideas on summer or too early given the need for Enzo? I think that this summer will feature a pretty active severe weather component from the Mississippi River Valley to the Ohio River Valley. I think the subtropical jet stream is going to be more active. I'm just not sure if we're dealing with an El Nino or a warm neutral state. I'm not sure about that yet. Um, and then the Atlantic hurricane season, I'm not sure yet. That really depends on whether or not we get an El Nino or not. Let's see. I'd be more worried about the city killer asteroid over 2% now in 2030s than in North Atlantic's current circulation. Yeah, yeah, just my. I'm telling you, now I know when I'm going to win the lottery, honey. It's when that meteor hits in the 2030s. Makes a lot of sense. Of course, that's going to be super outstanding. Let's see what else do we got here. Any other questions on Facebook or X? All right, here we go. All right. Wife and I just bought a condo in Ocean City, Maryland in January. Should have spent our winter there. Yeah, yeah, definitely if you like snow. Hey, Steve, for March blizzard of 2017, what all the ingredients came together to create that? Lived in Central PA and loved it. In that blizzard, you had a combination of good good high latitude blocking lining up. You had a good ridge out in the Rockies, which amplified the jet stream, and plenty of moisture transport. So that all combined to allow the cold air mass to build in and produce a pretty good snowstorm.
Bear with me, because Facebook hates me.
Facebook doesn't hate you. Facebook hates everyone.
Well, I mean, still, I count. I mean,
Facebook hates everyone, and then they take your face and use it for advertisement. In the meantime, I'm gonna have some tea. That's some good tea. All right. Let's see. I think we're almost at it's at 8:53, so we'll take this as last question.
Not last question.
Is there anything on Facebook?
More on YouTube, which is possible.
Well, let's see here. Let's see. Can places in Long Island still get some snow? I mean, all right. Well, here's the problem with your question. It's a very broad question because can you see flurries? Yes. Will you see 6 inches of snow? No. So, gotta be careful about those questions. I had a social studies teacher who was amazing in Eisenhower School, and he would always say, "Be careful how you phrase your questions," because he'd always turn it on you. Like, for example, "Can I go to the bathroom?" I don't know. Can you? Like, you see what I'm saying? So he was a smart ass because I'm like, you know what I'm asking. Come on, give me my pass. But he was a great teacher because he made you critically think. You know, how does this weekend look? Well, for the most part, the weekend is looking not too bad actually. Let's take a look. Look at the weekend here. It's actually pretty quiet. Saturday and Sunday, you got a few weak shortwaves passing through. Very, very weak clippers, so you might see a flurry here and there. but nothing really significant. There's no major storms or anything this weekend. Excuse me. And really, you could take that all the way into next week until the end of next week. It looks like February, well, let's just say, I don't know, the timing might be off to say that March is coming in like a lion, but it's certainly ending like a lion for February with a pretty good rainstorm on the way, which is something that we definitely need. So I think we pretty much covered everything on that. We answered a lot of questions. Now, what did we learn tonight? We learned that when the NAM starts producing major winter storm outputs, when everyone else says no, including its own companion models like the 3K NAM, we ignore it and we don't post the snow maps. We also learned why the pattern is not supporting a major winter storm and where the pattern is evolving towards. Definitely continue to expect the potential for some Arctic blasts, but as we move along over the next 15 days, those blasts will become shorter and weaker in duration and strength. So, with that being said, the idea that I had with this being the end of winter looks like it's panning out pretty much as expected. And although I know many of you have been looking for that major winter storm, it doesn't look like it's going to be taking place this year, unless you're in the Great Lakes. Well, at least you know that you're going to get an honest opinion. Yep. Yeah.
More stuff rolling in on YouTube and X.
Oh, well, let's see what we got here. All right. The models aren't wrong on Thursday. The chances of them being wrong, the reason why they're not going to be wrong is because the observations are what they are. Guys, there is not going to be a major winter storm, no matter how much you wish it, because of the observation. Forget the miles, throw the miles out. The observations I showed you tonight, fast moving, there's nothing to block it. It's over. Throw in the towel. Where's that Rocky meme? Throw in the towel. It's done. It's over. Let's see. Yeah. Let's see. Philly area could certainly see some flurries. That's about it. I'm not seeing much in the way of any type of significant snowfall. And here's the thing: once you get past March 15th, then you start talking about, well, you could get some snow on some bushes and grass, but you're not getting on the pavement, and then maybe on some car tops. I think that's it for tonight. To be honest with you, I'm going to shut it down for tonight. Before I know I'm going to be sneezing at like significant times in a few minutes. So I'm going to shut it down.
Thanks for the birthday wishes.
Yeah, see, thank you for the birthday wishes. We're going to have fun. We're going to have fun tomorrow celebrating, right? That's why we didn't do the live check because we're going to go out. We're going to have fun. We're going to harass people at the mall. It's going to be great, right? It'll be good. All right. So have a wonderful night. And as always, stay safe out there.